All right, this tape is on graphing the 6 trig functions: sine, cosine, tangent, cotangent, secant, cosecant, and looking at amplitude and period and shifting and that type of thing. So let's look first now at the basic idea of what's happening on a graph of a trig function. And that's this. Let's plot the sine of theta. Plot. Now I said it's plot. At the beginning right here, I'm going to kind of show you how the concept of plotting is, and then we're going to look at being able to sketch it and to kind of know the basic ideas of what's happening. Now, for the sine of 0 degrees, it's 0. So, well, let's see, we're going to go to 360. So let's kind of divide this up into 4 equal marks. And so that means this will be 360, 90, 180, 270. So 30 degrees would be about a third of that. Well, the sine of 30 is 1/2. Now let's come up here and make a mark at 1. So this is going to be 1 minus 1. The reason we're doing that is because sine and cosine is never greater than 1. So the graph's going to be somewhere in here. Well, the sine of 30 is 1/2, so that'll be right there. Sine of 45 is 0.7, so that's about right there. Sine of 60 degrees is 0.9. Sine of 90 degrees is 1. Sine of 120 is another 30 degrees over here. Is back to this point. So that's that one. And then 45 is 135 degrees, same as the 45, so it's this one right here. And then 150 degrees, the sine of 150 degrees is 0.5, so that's down here. And the sine of 180 is 0. So therefore the sine curve then is looking something like this. All right, 210 degrees, that's 30 degrees over here. Sine of 210 is a minus 1/2. 225 degrees is a minus 0.707. 240 degrees is 0.9. 270 degrees is a minus 1. 300 degrees, 315, 330, and so what we get then is the sine curve looks like this. And this is 360 degrees, 180 degrees, 270 degrees, 90 degrees, 30, 45, 60. Now look what's happening. Here's the things I want you to see. This really helps you back in the first part of this course in knowing the special angles. The sine of 0 degrees is 0. The sine of 90 degrees is 1. The sine of 180 degrees is 0. The sine of 270 is a minus 1. The sine of 360 is 0. The sine in quadrant 3 is negative. Quadrant 4, negative. Quadrant 2, positive. Quadrant 1, positive. So by picking up on these graphs, you can strengthen your previous knowledge of trig. Now please hear me. This is at 360 degrees. We call this 1. All right? Now if we were plotting this thing, now the difference between sketching and plotting is if we're plotting this thing exactly, making sure all the numbers are right, then what you need to understand is we have to mark this off in numbers, not degrees. So this becomes 2 pi, or 6.28. You would take a piece of graph paper and mark out here 6.28. 3.14 would be here, okay, or pi. 1.57 would be here, or pi over 2. Okay, and then 3 pi over 2. So that's what I'm saying to you. If you're going to graph these functions, then you have to get a graph paper and measure exactly 6.28 out here for the 4th mark. Therefore, if this is 1.57, then 1 is back in here, so that makes this distance 1 here. And so what happens, and you do this on your calculator, the sine curve doesn't come up very high here compared to being out here a distance of 6 inches. It comes only 1 inch high here and low. So what I'm going to do in this tape is show the concepts of where it comes up, where it crosses the x-axis, and these type of numbers, and not get involved in the exact measurement so much. Now in the notes, some I do with radians, and some I do with degrees. Okay? That's not the point. At the first part of this tape is the concept is, what does a sine curve look like? What does a cosine curve look like? What is a tangent curve, cotangent, secant curve? Where does it cross the axis? Where is it at maximum and minimum points? And those things, all right? All right. So now let's look at the first part of the concept of the tape that I want to teach, and that is, what does a sine, cosine, tangent, cotangent, secant, cosecant curves look like? Well, here's how you do them. Okay, sine. Sine is, step 1, draw xy axis. Now when I say xy axis, this is really the theta, and this is y. Usually when you graph, you have y equals the sine of theta. All right, so the sine curve is, step 1, draw the axis. Step 2, 4 equal marks. Step 3, draw the curve in. The sine curve goes like this. Starts here, comes up, comes back down, comes back. Step 4, plug in the numbers. Well, this is 360 degrees. So watch this. If this is 360, then half of that's 180. Half of this is 90, and then this added to this is 270. Now pay attention to that process, because this number is going to change on us later on. And when you do, you put this outside number first, this fourth mark, and then you take half that to get here, half that to get there, add these together to get that. And then how tall does the sine curve go? 1 minus 1. That's it, sine curve. Starts at the beginning, comes up the first mark, back to 0 at the second mark, minimum third mark, back to 0 fourth mark. Quadrant 1, sine is positive. Quadrant 2, positive. Quadrant 3, negative. Quadrant 4, negative. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is minus 1. All right? That's the process. All right, now let's look at cosine. Okay, what happens if we want to do the cosine curve? Well, step 1, xy axis. Step 2, 4 equal marks. Step 3, cosine curve. Cosine curve starts here, comes down to 0 at the first mark, minimum second mark, back to 0 third mark, and comes back to here. Okay, last step, plug in the numbers. So we'll put 2 pi here. Half that is pi, 180 degrees. Half that is pi over 2. And then this added to this is 3 pi over 2. And this is 1 and a minus 1. So the cosine curve starts at its maximum point, 1, comes to 0, minimum, back to 0, maximum. Quadrant 1, cosine's positive. Quadrant 2, negative. Quadrant 3, negative. Quadrant 4, positive. Cosine 90 is 0. Cosine of 180, minus 1. Cosine of 270 is 0. Cosine of 0, 1. All right, so that's the cosine curve. Now, before I go to some other ones, you need to understand these curves go on forever. Okay? They just keep continuing. All we're plotting or sketching is what's happening in 360 degrees. All right, let's go now to the tangent. Okay, the tangent. Tangent, step 1, xy axis. Step 2, 4 equal marks. Step 3, tangent curve. Well, the tangent curve at the first mark has an asymptote, and at the third mark has an asymptote. And so what we do is draw the curve here. It doesn't touch. Quadrant 2 comes up here, comes to 0, doesn't touch. Quadrant 4. So the tangent curve is like that. Last step, put in the numbers. So this is 360, this is 180, 270, 90 degrees. Quadrant 1, tangent's positive. 90 degrees, not possible. That's what these asymptotes means. 89 degrees, this is very large. 89.99, tangent's really large. Very close to 90 degrees, tangent's almost infinity. On the other side of 90 degrees, quadrant 2, it's negative. Quadrant 3 is positive. Quadrant 4, negative. Tangent of 180 is 0. Tangent of 270 is not possible. Now, on the tangent and cotangent, we don't worry about this number out here. Now, what that number does is simply makes this thing come in like this, or it may go up real quick. We're not worried about that. All we want to know is the basic sketch, which it starts at 0 and goes to infinity. Starts at negative infinity, goes to 0 in quadrant 2. From this mark to this mark, starts at 0, goes to infinity. So that's what we're after. All right? Cotangent. All right, so the cotangent. Step 1, draw the axis. Step 2, 4 equal marks. Step 3, draw the curve in. Now, the cotangent dotted line is at the second mark and the fourth mark. And the cotangent comes from infinity, comes down to 0, and goes to negative infinity. It comes from infinity, goes to 0, goes down to negative infinity. And again, this is 360 degrees, 180 degrees, 90 degrees, 270 degrees. And again, we don't care about where the ones and minus ones are. All right. Cotangent positive in quadrant 1 positive, quadrant 2 negative, quadrant 3 positive, quadrant 4 negative. Cotangent of 0 degrees is not possible. Cotangent 90 is 0, so on and so forth. All right. All right. What comes after cotangent? Well, I guess it's secant. So let's look at secant. Secant of that. Step 1, XY axis. Step 2, 4 equal marks. Step 3, curve in. Secant is like tangent dotted lines. First and third. Secant, oops, now this 1 comes into play, this 1 and minus 1. Secant starts at 1 and goes up to the dotted line. Why? Secant, cosecant, never less than 1, so there'll be no curve in this area between 1 and minus 1. The curves will be up here or down below. All right, secant curve comes from a negative infinity up to minus 1, then goes back down. And then over here, curve comes down. Now remember, what this secant curve looks like this is forever, these like U's, upside down U's. But all we're drawing is 360 degrees, 180, 270, 90 degrees. All right? Secant, quadrant 1 positive, quadrant 2 negative, quadrant 3 negative, quadrant 4 positive, just like the cosine curve. Here's the cosine curve, which is reciprocal. Cosine curve is reciprocal. In other words, the reciprocal of this is flipped over. Okay? Reciprocal of 1 over 0, which is not possible, is 0 over 1. Reciprocal, reciprocal, so it's flipped over like that. All right? Cosecant curve. Cosecant. Step 1, axis. Step 2, 4 equal marks. Step 3, cosecant curve is like cotangent. Second and fourth mark. Again, the 1 comes into play, minus 1. The cosecant is here and here. All right, so this would be 2 pi, 360 degrees, pi, 180 degrees, pi over 2, 90 degrees, 3 pi over 2, 270 degrees. Cosecant positive in quadrant 1, positive quadrant 2, negative quadrant 3, negative quadrant 4. Cosecant of 0 is not possible. Cosecant of 90, 1. 180, not possible. 370, minus 1. So, okay. Now that gives us the 6 basic trig function graphs. Just the concept of where they start, how they come down to 1 or never get larger than 1. What you should do is kind of turn off the tape maybe, and or just put it on pause and take your calculator and go through some of these like it says in the notes. What we're going to do next in the study is to look at the 3rd page of the notes at what happens if we put a number out in front of the sign. What happens if we put a number in front of the... All right, looking at right at the top of the 3rd page where it says y is equal to a sine b times parentheses x plus c. All right, other words, looking at the first example, what is y is equal to 4 sine of theta or x or whatever. The number in front is called the what? Amplitude. Amplitude. Now what that says is, what's the rule about the sine of theta? It never gets larger than 1 or less than minus 1. Well, this 4 then would be multiplying 4 times the largest value. So if I put a number 4 in front of this, then that makes the curve go up to 4 as its maximum, and minus 4 is its minimum. All right, then what we'll do is look what happens if you put a number in front of the theta right here, that b that they're talking about. Well, what you do is divide that into 360 or into 2 pi. See, this is a 1, 360 divided by 1, that makes our 4th mark 360. Then what happens out here if you have something added to the angle? All right, we'll talk about that. All right, so let's look at what happens if we have a 4. All right, here's how you sketch this. Here's how you sketch this. Step 1, axis. Step 2, 4 equal marks. Step 3, draw the sine curve in. Sine curve comes up, 1st mark, 2nd mark 0, 3rd mark minimum, 4th mark there. All right, last step, plug in the numbers. The numbers are still 360, 180, 90, 270. But now this is 4, and this is a minus 4. Whatever number's in front now takes that 1 that we were dealing with in the sketching and now makes it 4. So what we're saying is this sketch is, I know that this goes up to maximum 4, minimum minus 4. It crosses at 180. I know that, all right? So that's why that sketch gets the job done for me. Now the actual graph on this would be, okay, the actual graph is where you would have to come in here and make this 2 pi. All right, so this would be pi and 3 pi over 2 and pi over 2. Well, that's 6.28. So that 4th mark, you would measure it out here on graph paper, 6.28. Well, what it means then is if that's 6.28 out here, then this has to go up to 4 inches. So what happens is that 4 makes this come way up and down and back like that. But still, it tells us the same thing. We don't have to draw it exact to get the concepts we need to know. Now, if a problem says graph it, you've got to know the exact plot for some reason. And I'll explain the very last page of the notes why sometimes this is important. Then you would do that. Otherwise, that curve represents this curve. It says this is 4. That top point's 4. Says this is 0, 0, minus 4. Tells us where it crosses. All right. All right, next example. Okay, next example is 2 cosine of 3x. Step 1, xy axis. Step 2, 4 equal marks. Okay, step 3, cosine curve. Cosine curve starts here, comes down to the first mark, negative, third mark, back to its maximum. Step 4, plug in the numbers. Aha, now this would be 2, and this would be minus 2. Now, this is not 360 anymore. Listen very closely and watch out for this. Whatever's times the x is divided into 360. So we have 360 divided by 3. So this is 120 degrees. The fourth mark is called the period. It's how many degrees it takes for this to start repeating. Okay? Let's look then at, for a minute, the cosine of 3 theta. Just watch and listen. 0 degrees. Cosine of 0 degrees is 1 times the 2, then that makes that 2. 30 degrees. 3 times 30 degrees is 90. Uh-oh. Cosine 90 is 0. So in 30 degrees, it's already down here to 0. Okay, 60 degrees. 3 times 60 is 180. Cosine minus 1. So at 60 degrees, it's already here. 90 degrees, 270, 0. 3 times 120 degrees is 360. You see, so whatever this divided into 360 is where it's going to start repeating. So the period of that is called 120 degrees. Okay? Because of this divided by 360, or 2 pi. 2 pi divided by 3, okay? Pi over 360 times 2 is 120 degrees. So that means this cosine curve, the period is 120 degrees. The fourth mark is 120. So this is at 90. Half of 120 is 60. Half of that's 30. These two added together is 90, and so it gives us that process. Now, see what's really happening here. Let me erase this and kind of go over again. What's actually happening if I were to draw this exact, is let's say this is at 6.28, okay? Or 360 degrees. Okay? And we come in here and make our 4 equal marks. Well, the cosine curve is supposed to be like this. However, this says we'll have 3 of those. Okay? So this is 360. This is 180. Okay, this is 90. So here's 120. And so what happens is we get, okay, 3 of them. Okay, we get 1, 2, 3 of them. We get 3 of the cosine curves in the space of 360 degrees. Okay, again, you should take your calculators and experiment with stuff like that. Go in here and make numbers here and put numbers here and see what it does. Okay. All right, next example. Next example is y is equal to 5 tangent of 1/2. I'm going to just call it x here. The notes have theta, but just to say it doesn't make any difference. 4 equal marks. Okay, so 4 equal marks. Tangent curve is dotted line here, dotted line here. Tangent curve is, okay. Now, 360 divided by 1/2, you invert and multiply. 360 divided by 1/2, therefore this is 720 degrees. Okay, this would then be 360, and this would be 180, and then added that, make this 540. Okay. Amplitude. What does the 5 do? Well, the 5 doesn't do anything. You can put it on the problem. You don't have to put it on the problem. Okay. What the 5 does on tangent and cotangent is, in other words, if I put a 5 on there, that makes this, normally this curve look something like this. Comes over and comes up. The 5 makes it just get up there quicker. As far as the sketching purposes, it does not affect the basic sketch of the curve. All right? Now, if you look at your notes, you see that what this 1/2 does is really stretch this out. That's 720 degrees. Now, that's 4 pi. That's 12. So that would be over here 12 marks. Okay, so what it does, it really stretches the tangent curve out, but it still looks like the basic concept there. All right, next one. Okay, the next one, y is equal to 3 cotangent. Well, step 1, 4 equal axis. Step 2, 4 equal marks. Step 3, cotangent curve. Cotangent curve is the second dotted line, and fourth mark is the dotted line. Cotangent curve is. And just stick a 3 over here and a -3 anywhere you want to. All right. Next one, secant. Okay. We want to do secant of pi over 2x. Step 1, axis. Step 2, 4 equal marks. Step 3, secant curve. All right. Secant curve is dotted line at the first mark, dotted line at the third mark. Secant curve starts here, comes up, comes here, comes down, comes down. Then this is 3 and -3. Now remember, the secant curve never is less than 1, so it's never less than 1 times 3, so it's not going to be less than 3. So the secant curve is above 3, below -3. All right, now here's something different now. We have a pi over 2 in front of the x. So we divide that into 2 pi, So if we divide 2 pi by pi over 2, if this is a pi in front of the x, then we must divide it into 2 pi, not 360 degrees. All right, so 2 pi divided by pi over 2. Inverting and multiplying, the fourth mark is 4. Not 4 degrees, but 4. See, if I were drawing this accurate, then that means the distance here would be 1 inch, 2 inches, 3 inches, 4, or 1 mark, 1 centimeter, 2 centimeters. Then this distance would be 3 centimeters, or 3 inches. So this distance ought to be that distance right there if I were drawing it accurate. And again, you should be taking your calculator and drawing it on your calculator and kind of seeing what's happening. Draw several on the same picture so that you can see what's happening. In other words, draw secant of x, draw secant of pi over 2x, draw 3 secant of pi over 2x, and things like that, and see what it does. The number out in front pushes this up, moves it down, separates it, gets it further away from the axis. This number moves it in here like an accordion, okay, or stretches it out. All right, so this mark is 4, halfway is 2, half that's 1, this added to that's 3. All right, across on the page you see what really happens if you measure it accurate. All right, now let's take the last one on that page. Okay, y is equal to 1/2 cosecant. All right, step 1, axis. Step 2, 4 equal marks. Step 3, cosecant curve. Cosecant curve, like cotangent, dotted lines. Second, fourth mark. Cosecant is. And this distance is whatever's in front, 1/2. Minus 1/2. All right, nothing's in front of the x, therefore this is 2 pi, or 360 degrees. So this is half that pi, pi over 2, 3 pi over 2. Now, what I've tried to do here is to show you what the amplitude is, what the number in front of the trig function does. All it does is move these points up and down. Okay? But as far as the sketch, you just mark it, call it whatever that is. The number in front of the x then moves these 4 points, these 4 marks that we have, pushes them together like an accordion does, or stretches them out. All right? And that happens to be 360 divided by this happens to be the period of that particular graph. All right, let's look now what happens if we deal with the shifting. Now in this problem we have all those numbers involved. We have the amplitude, the number out in front, which is a 2. We have, now what we have to do here is factor. We must factor and make this just x or theta, and then plus or minus. So when if the number's in front of the theta, we must factor it out. So that's the period now, 360 divided by 3, or 2 pi divided by 3. And then this number, what this number now does, it takes that regular curve and just shifts it, or shifts it. Okay, so let's see what happens now. All right, now listen to the method to do this on sketching. Step 1, axis. Step 2, 4 equal marks. I don't want to put them in dotted. All right, so the curve should look like, let's see, this would be up here at 2, okay, and so the curve would come down. Now I'm just sketching this. Oh, I'm sorry, that's a cosine curve. Whoops, cosine curve. No, 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 no. Cosine curve. Sine curve is come up here, come back down. Sine curve. All right. That's where it should be if I didn't have this 20 degrees here. All right, let's see. This would then be 2, and this would be minus 2. So we'll go ahead and put those in. And this would be what? 360 divided by 3 is 120. I'm going to put it dotted 120. And so this would be what? 60. And this would be 90 and so on. Okay. So each of these are 30 degrees. 60, 30, 90, 90 to 120 is 30 degrees. Okay. So each one of those are 30 degrees. Now the 20 degrees, it then takes this thing and moves all those marks 20 degrees. Well, which way? Well, here's how you determine it. The sine of 0 is 0 normally. If I put 0 degrees in here, what do I get? Well, I get 20 degrees times 3 is 60. Sine of 60 is the square root of 3 over 2. So that's the square root of 3. So the 0 degrees is up here now, okay? So what that means is this thing was shifted that direction. So what we do is this. We then shift it. From these dotted points, we shift it 20 degrees back. Now remember now, this was 30 degrees between here. So 20 degrees back would be 100. All right, this was 90. So 20 back would be 70. Okay, this was 60. 20 back would be 40. Look here, still 30 degrees between them. This was 30, back is 10 degrees. This was 0, back 20 degrees. And now we draw in the curve. And look what happens. It takes this curve and just moves it back 20 degrees. So it takes this and moves all the 4 marks, and really have 5 marks when we start considering the origin. It takes and moves this mark 20, this mark 20, this one 20, this one 20, this one 20. So it moves it back. So now, this is what? Amplitude. How tall it gets, max and minimum points. This is how many degrees it takes to repeat, 120 degrees. See, this is minus 20. Minus 20 degrees. From there to 100 is 120 degrees. And then whatever this number is, shifts it. Now watch, listen. positive, shifts it that direction. If you put a negative, it shifts it this direction. That's all there is to it. If you'll follow my procedure, if you have a number in here, okay, then you simply do this without the number, dotted, and then just shift it that many degrees. All right. Now let's look at the next example. Okay, and all this example is what happens if we have a negative involved in it. All right. Well, let's see. Cosine curve. Step 1, axis. Step 2, 4 equal marks, dotted. All right. Step 3, cosine curve. Cosine curve starts here, comes down. All right. And the number in front of the x is a 1, so this is 360 degrees. I'm going to go ahead and do 2 pi. Right. So if that's 2 pi, then this is pi, and this is pi over 2. Well, now watch. If this is pi and pi over 2, halfway is pi over 4. And that's what this is. All right. Now what this says is a negative. We're going to shift it to the right. So we're going to take this point and move it. We're going to take the beginning and move it 45. We're going to take this 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 45. All right. Now this is 360 degrees right here. Plus 45 is 405. Or 2 pi plus pi over 4. Okay, so 2 pi plus pi over 4 is what? This is 8 pi over 4, so that would be 9 pi over 4. Or 2 1/4 pi, so it's 9 pi over 4. Well, half of that would be what? 9 pi over 8. Half that would be 9 pi over 16, and then these together, 27 pi over 16. Well, anyway, let's go back to the graph. Here's the 5 marks. Cosine curve starts here, comes down, comes to minimum here, comes back, comes up to here. Okay, and then what you should do for textbook purposes is finish this graph over here up to that line. You can, as far as I'm concerned, you can draw it past that if you want to, and so on. But this is telling us that the cosine curve now starts at 45 degrees, okay, and goes to 405 before it starts repeating. All right. Oh yeah. What about the first? Well, we'll just call this 3 halves, and this a minus 3 halves. Okay. When we're sketching it. Because this is what we're wanting to know. What we're trying to teach you is this is the shift, this is what makes it move, this number in front of the x is what helps repeating the concept of period, and the number out in front, it gives its height. Okay, its max and minimum values. All right, now the next thing is what happens if there is a minus in front of the curve, okay? What happens to the graph if there's a minus? Well, here's all there is to that. It's a very simple concept. Let's go back and sketch 4 equal marks. Sine curve should look like this. What the minus does, it mirror images, it flips it over, okay? In other words, if this was a positive one, it now becomes a negative one. So a negative in front of the, a negative in front of the just flips it over. Okay, a minus cosine. Let me sketch that for us. A minus cosine. All right, 4 equal marks. Cosine curve looks like this, supposed to. Negative cosine then would be coming down here, going up there, coming down. So a minus in front of a trig function simply flips it over. And it's a simple concept. It was a positive 0.707. It is now a negative 0.707. Okay, it was a negative 0.5. It is now a plus 0.5. So that's all a minus does. All right, now let's look at the last two examples on the notes, and a little more complication involved. All right, now look at example 16. Now this is where graphing is important, not plotting, not sketching, but graphics is important. This is where you have to have it really figured out with a ruler and exact values. The graph of y equals x plus cosine of x. So what we need to do then is this. We must graph y equals x. So we do y equals x. So the graph of y equals x is 1, y is 1. Not angles, not degrees or anything, but x is 1, y is 1. X is 2 is y is 2. All right, so we're going to graph y equals x. And y equals x then would be this 45-degree line. All right. Now we need to graph y equals cosine. Y equals cosine is, let's see, when x is 0, y is 1. So we're here at 1. And then at 90 degrees, that's 1.57. So there's the 90 degrees. Then 180 is 314, so we come over here at 3.14 and we come down 1. All right, and then 270, well, let's come over to 628. 628 is plus 1. And then this is 3.1 plus 1.57, so that's what? About 4, 6 or 4, 7. So over here is the fourth mark. Therefore, the cosine curve is right. Now this is placed in exact measurements now. We can't do that, just 4 equal marks. All right, now to do this, it's a very simple concept, but it takes rulers and everything else. To do y equals x plus cosine of x, or minus, or whatever, we now just come over here and measure. Let's just take it each point. At 1, we add the distance of the cosine to the distance of the y equals x. Here's the y equals x. So just onto the y equals x, let's add and subtract this. So we will add this distance right here to that. Okay, starting at 0 here. Now this added to this. So here's our first point. And then we'll take it 1. We'll add that. At 2 now, this is a minus value. So we will subtract this distance from 2. So we'll subtract that distance. At 3, we have this distance. So we'll take a ruler or take some kind of measurement and come up here and subtract this. Okay? At 4.5, it's just that point. At 6.28, it's this much added to it. So what we're going to get is a curve along that. But again, now let me go back and say to you, if you had x plus cosine of x, you will come and take the, and it doesn't make a difference which one, but we'll take the curve y equals x, and we will just add to it the cosine. So we pick any points we want. Another way of doing this is just drawing a bunch of lines up. Okay? And just along this line, add this distance to this curve. Along this line, add this distance, which is a negative, to that curve. So we come down. Along this line, add this distance, which is a negative, so we subtract it. If this had been negative, okay, negative, two ways of doing this. One is subtract. Come along and subtract this distance from the line. So that would be there. Subtract this distance. So that would be there. Okay, subtract this. Well, this is a negative, so subtracting a minus and a minus would make it a positive, so we'd end up adding it. This is negative, so we're subtracting it, so it's a minus, so it'd be positive, so it'd be there. So x minus the cosine curve then would be going along the line also. Now, the two things I'm saying to you is to do curves that have trig functions and x's, then it must all be in radian measure. It must be exact numbers, 6.28 for 2 pi. All right? The other shortcut method that I was going to show you, a minus, what does a minus do? A minus is reverses, so it would take this dotted line here and switch it up here, and then I can just add those, and I end up getting the same points. All right, now let's look at the last example, kind of where you can put all this together in application. Now let's look at the last example, the notes. And I have a lot of things left out on the notes, but you have to watch the tape and write some notes down yourself on how to do this. Now, it says figure out the equation of the trig function that best fits the data so that we can figure out what's going to happen some other time, another month, or have an estimate. So we have the data that says, okay, at 0 it's 65, and in other words, 1st of January, let's say, 1st of February, then we have temperature was 60, or we can say the average for the January was 65, average for February was 60. For whatever date we're talking about, number 2, it was 61, the 3rd for 3, which is the 4th measurement, 67, and so we plot this. And listen closely. When you start doing this, the first thing you better do is go change your range. All right? So go in the calculator and change the range to what? I would do -1 to 12. Increments of 1, and then the y's would be, let's say, from 50 to 110 by increments of 10. So when you graph this, the first thing to do is to, hey, I better go change my range to fit these set of numbers. So that's the first thing to do with your calculator. All right? Well, let's continue then. All right, then it says stat. All right, to do this, to get this graph, then we'll do what it says. We'll hit the stat button. Okay, and then we'll do edit. All right, that's the F2 button. So we do the F2 button. And then it's going to call up some numbers here when you do that. And so what we do is just hit the arrow button down. It goes through that name, arrow button down. And then we start, and it comes in here and it says X1. Well, then you put the number in, enter. Then that'll be 0, and then enter 65, enter, and then 1, enter. In other words, 1, and then enter 61, and then enter 2, and so enter all the data. All right, now when you get all the data entered, then you want to hit second draw F2, and F2 is scatter, and it'll show you these dots. All right, now we've got the dots in there, so now let's go do pencil and paper and figure out what equation goes with this. Well, I'm going to say, hey, look, the low is 60, the high is 100, so halfway between there is 80. So I'm going to let that be my axis. All right, listen closely now. What we're doing is we're going to do A, trig function, B, x plus c plus d, where d is my curve doesn't come down here across this axis. So what I'm going to do is move my axis up 80. So this is going to be plus 80. Right? This is not part of the amplitude, period, shifting. This is just the curve is up there. This is like at y equals x. This would be x plus the cosine of x. So we're just going to say plus 80. Now we're going to work everything on this curve. Well, I'm going to say, hey, this is a sine curve right here. Sine curve. And it's moved over. It's moved over, whichever way we want to think of it. Now we could think of doing a minus sine curve where it comes down. But I'm going to do sine curve at this point. So I'm going to put sine in here. Now, how far is it up? The maximum point here, minimum point, is 20. So the shift, we haven't got to it yet. What we're going to look at from here to here is the sine curve. So that's 20. So that's what the amplitude is. So that goes out in front. All right, now the shift. The shift is whatever this is. Now, 4 is 77. All right. And over here at 10, it was 83. So that's a shift. The shift is whatever it is from here to here, which is, we're going to just use 4. So we'll put 4 there. Well, wait a minute now. Plus shifts it that way. Minus shifts it this way. And so we're moving it over this way. So we better make that a minus. All right. Now what is the period? Well, half of this sine curve is about 6. In other words, this is 4 point something is 80, and 10 point something is back to 80. So half of that deal is 6. Therefore, the entire sine curve, one part of it, is 12. It's 12. Well, that's equivalent to 2 pi. So I'll divide both sides by 12, and we get pi over 6. And that's the number I'm going to put right here. And now if you'll go graph the sine, 20 times the sine of pi over 6 in parentheses times x minus 4 plus 80, it will give you a curve that's almost fits this. Not quite, but almost fits it. You can go in and adjust this and make it a little more accurate. But let's show you where everything comes from. This plus 80 is if I'm going to move my axis up in here to fit it. All right? This number is this amplitude. How far is the maximum height above this line and below that? And you want to put this line in between the highest and the lowest point. Okay, so that your amplitude will be the positive maximum, the negative minimum. All right, so that's where that comes from. Then this will simply come from wherever you want to start the beginning of your concept of your curve back to the origin. That's how much it's shifted. So that'll be that number. And you can do more accurate work here and try to get this a little closer, like 4.1 or whatever. Experiment with it with a calculator. All right, then this number is the period, remember? It's divided into 2 pi. Whatever this is, divided into 2 pi. So I want 2 pi divided by the period to equal the 12. See, because I said from here to here was 6 approximately, and so I want 2 pi divided by that. So therefore the period then is 2 pi divided by 12. That's how I get that. All right, so that's how you can use these concepts of what this number is, what this number is, and what the shifting is to be able to come up with equations that satisfy data. All right, this concludes then the tape on graphing.